warahmatullahi wabarakatuh. My name is Nur Syafiqah binti Muhammad Izzat. My metric number is 202728. Today I will present about dimensional analysis. Definition of dimensional analysis is the analysis of the relationships between different physical quantities by identifying their base quantities and units of measure and tracking this dimensional as calculation or comparison or perform. Dimensional homogeneity. The law of dimensional homogeneity states that every additive term in an equation must have the same dimensions. For example, the change in a total energy of a system, compressible closed system, from one state or time to another as illustrated. The total energy of the system is given by the equation. If at some stage of an analysis we found ourselves in a position in which two additive terms in an equation have different dimensions, this would be a clear indication that we have made an error. In addition to dimensional homogeneity, calculations are valid only when the units are also homogeneous in each additive term. It is wise to write out all units when performing mathematical calculation in order to avoid such error. Buckingham's pi theorem definition: if there are n variables in a problem and these variables contain n primary dimensional, for example mass, length or time, the equation relating all the variables will have dimensional group. Buckingham referred to this group as pi group. The Buckingham pi theorem indicates that validity of the laws of physics does not depend on a specific unit system. A statement of this theorem is that any physical law can be expressed as an identity involving any dimensional combination, ratios or product of the variables linked by the law. The final equation obtained below. But the Buckingham pi theorem provides a method for computing sets of dimensional parameters from given variables, even if the form of the equation remains unknown. However, the choice of dimensional parameter is not unique. Buckingham's theorem only provides a way of generating sets of dimensional parameters and does not indicate the most physically meaningful. Most importantly, Buckingham's theorem describes the relation between the number of variables and fundamental dimensions. This method offers the advantage of being more simple than the method of solving simultaneous equations for obtaining the values of the indices, the exponent values of the variables. The method of repeating variables: the first one, we have to list the parameter in the problem and count their total number. List the primary dimension of each of the n parameter. Set the reduction as the number of primary dimension. Choose a repeating parameters. Construct and manipulate as necessary. Write the final functional relationship and check your algebra. Thus, we rearrange it. We get that CHP with the power of 1 over 2 divide by sigma with the power of 1 over 2. This, we repeat the same with pi 1 and we get C equal to 0, B equal to 0 and A equal to minus 1. Hence, pi 2 is equal to lambda over h. Thus, we rearrange it CHP and we get this equation.